This will be for the con exercise, dependent and independent events. All right, some notes before we begin. If events are independent, that means that one event does not affect the other. And the way to test if events A and B are independent, if the probability of A times the probability of B equals the probability of both A and B, then the events are independent. Now, if the events are independent, the probability of A given B equals the probability of A. And why is that? Because the events are independent. So even though it's given that B occurred, that has no effect on the probability of A. So if the events are independent, the given B does nothing, and the probability of A given B is just the same as the probability of A. The given B doesn't do anything if the events are independent. And works the other way around as well. If they're independent, the probability of B given A is just the probability of B. The given A part does nothing because the events are independent. And we said when the events are independent, we said that the outcome of one does not affect the other. Okay, Bilal's favorite colors are red and green. He has one red shirt, red hat, green scarf, red pants, green pants. So he selects one garment at random. A selects green, B chooses a scarf. Okay, and then they ask us a bunch of questions based on dependence. You have to choose all answers. So basically, let's find out if they're independent. All right, A means that he selects a green garment, and B means that he chooses a scarf. So the probability of A, which is going to be a green garment, how many green garments are there? 1, 2, 3. That's going to be 3 out of how many? 1, 2, 3, 4, 5. 3 out of 5. Probability of B. B is that he chooses a scarf. All right, let's see. How many scarves? Right here, green scarf. That's just 1. And out of how many garments? We said 1, 2, 3, 4, 5, 6. All right, I made a mistake on part A. It's not out of 5, it's out of 6. All right, 1, 2, 3, 4, 5, 6. All right. And now, let's find probability of A times the probability of B. That's going to equal 3 over 6 times 1 over 6. All right, canceling fractions. 6 divided by 3 is 2. 1 times 1 is 1 in the numerator, and 6 times 2 is 12 in the denominator. Now let's find the probability of both. A and B. Okay, A is a green garment and B is a scarf. Do we have any green scarves? Yes, we do. All right, because A is green and B is scarf, so we have to find the overlap, A and B. We have one green scarf, and that's out of how many garments? 6, 1 out of 6. All right, so these are not equal. 1/12 does not equal 1/6. So these are not independent. These are not independent. Okay, so that makes them dependent. And that should be the final answer, if I'm not mistaken. That makes them dependent on each other. Probability of A given B equals the probability of A. We said this is only true when it's independent. B given A equals probability of B. Again, this is only true when it's independent. This says independent. That's not true. D, the outcomes are dependent. That's what we said. And E is the test that we just did. We said that was not true. All right, so the only one that's true is the one that's dependent. Suppose Adam rolls a fair six-sided die and a fair four-sided die simultaneously. A is the event that the six-sider is even. B is the event that the four-sided is odd. Using the sample space, answer the questions. Okay, probability of A, the probability that the six-sided die is even. That is pretty easy. Okay, we already know it's 1/2. But let's make sure. If there's 6 sides and we're looking for an even, well, if there's 6 sides, that means it goes 1, 2, 3, 4, 5, 6. And how many of those are even? 1, 2, 3. 3 out of 6, which just equals 1/2. The probability of B that the four-sided die is odd. Again, that's easy. The four-sided die has 1, 2, 3, 4. And how many of those are odd? Just 1 and 3. So the probability of B that the four-sided die is odd, it's just going to be 2 out of 4. Which again just equals 1/2. All right. So let me erase this and put the 1/2 in the box for each one. Probability of A is 1/2. And the probability of B is 1/2. All right. Let's move on to the next question. Third question, what is probability of A and B that the six-sided die is even and the four-sided die is odd? Well, here's the thing. We are rolling these dice. They're 2 separate dice separately. They're 2 separate events. One does not affect the other. Okay? And that means these events are independent. So all you have to do, if the events are independent, that means the probability of A and B is going to equal the probability of A times the probability of B. All right. This is if they are independent. And we know they're independent because it's 2 separate die. One does not affect the other. All right, so for A and B, probability of A we said was 1/2. Probability of B we said was 1/2. And of course, 1/2 times 1/2 is 1/4. So that goes in the box, 1/4. Finally, they ask, are they independent? Yes, we established that already. Because it's 2 separate events. One has nothing to do with the other. All right, there are 300 students in 12th grade. 120 have at least one sister. 100 have at least one brother. Out of the students that have one brother, there are 40 who have at least one sister and one brother. Let A be the event that the student has a sister. B be the event that the student has a brother. Let's answer the following questions. All right, what's the probability of A that the student has a sister? That's pretty easy. How many of them had a sister? Well, it says 120 had at least one sister, and that is out of a total of 300. So it's just going to be 120 out of 300. Let me see if it helps to reduce. Hold on one sec. Okay, it might be better to reduce. So if we did 120 out of 300, divided by 10, top and bottom, we have 12 out of 30. And 12 divided by 6 is 2. 30 divided by 6 is 5. So it's 2/5. All right, so instead of writing a big fraction, I'll just write 2/5. Pretty sure they would accept the decimal as long as it's not repeating. What is the probability that the student has a brother? All right, let's see. How many have a brother? 100 have at least one brother, and that's out of 300. All right, so that's going to be 100 out of 300. And divided by 10, top and bottom, if you just cancel the 0, that's going to be 10 out of 30. And divided by 10 again, if you just cancel the 0, that's going to be 1/3. So the probability of B is 1/3. What is the probability of both A and B? All right, what is the probability of A and B that the student has a sister and a brother? All right, it says right here, out of the students that have at least one brother, there are 40 who have at least one sister and one brother. Okay, really this line doesn't matter right here. The point is there are 40 who have at least one sister and one brother. There's 40 that has both. Okay? So the probability of both A and B, there's 40 that have a sister and a brother. And that's out of 300. All right, I know it says out of the students that have at least one brother, but that would be A given B. This is A and B, so we're basically doing it out of the entire total. Okay, so 40 out of 30. If you cancel the 0, we have 4 over 30, and divide by 2. These are both even numbers. 4 divided by 2 is 2. 30 divided by 2 is 15. So for A and B, it's 2 out of 15. Remember, for A and B, make sure you select it out of the total. There's nothing given here, so don't say given that it's at least one brother. This is out of the whole total. All right, so for A and B, it's 2 out of 15. And then finally, the probability of A given B, that the student has a sister, given that he or she has a brother. All right, probability of a sister, given that he or she has a brother. It says, now we have to limit ourselves to the ones that are given that they have a brother. So it says, out of the students that have at least one brother, there are 40 who have at least one sister and one brother. So let's see. It's given that the student has a brother, and 100 of those have at least one brother. So that goes in the denominator. All right, the given amount goes in the denominator, and 40 of those have at least one sister and one brother. All right, if we reduce that, cut the 0, 4 over 10 is the same as 2/5. Final answer. All right, so A given B is 2/5, and the probability of A equals 2/5. So, let's see. Does A given B equal the probability of A? Yes. We can see right here, A given B is 2/5. Probability of A is 2/5. So yes, A given B equals A. So B is not true. And we said at the beginning, if A given B equals the probability of A, that means the given B does nothing. Okay, so that means the events are independent. All right, we said that in the beginning of the notes. If this is true, they're independent. All right, last one. Anwar selects a card from the following 6 cards. 9 of hearts, 5 spades, 6 hearts, 2 spades, 4 hearts, 7 hearts. Let A be the event he selects an even, B be the event that she chooses a heart. Okay, so we have to do the test. Let's first do the probability of A. That she selects an even number. How many are even out of these? 1, 2, 3 out of 6. Probability of B. B is that she chooses a heart. How many hearts? 1, 2, 3, 4 out of 6. Very good. And now the probability of A and B. Or you can say the probability of both. All right, it has to be both even and a heart. So for both, we have to look for both even and a heart. That's odd heart. That's not a heart. That's even heart. That's not a heart. That's even heart. That's not even. So it's going to be 2 out of 6. All right, and now we have to do our test. All right, so let's do probability of A times probability of B. And we're going to see if it equals A and B. Probability of A is 3 over 6. Probability of B is 4 over 6. And reducing fractions, 6 divided by 3 is 2. And these are both even. 6 divided by 2 is 3. 4 divided by 2 is 2. All right, numerator is 1 times 2. And now, wait, we have 2 over 2. So this is just times 1, and we're left with 1/3. And probability of A and B, 2 over 6 is the same as 1/3. So yes, they are equal. That makes them independent. All right, if P of A times P of B equals P of A and B, they are independent. So we said at the beginning, if they're independent, A given B equals A because the given B does nothing. And B given A equals B because the given A does nothing. And we just ran the test to say that they were independent. D says they're dependent. That's not true. E, we just did that test and we found that to be true. So it's all the answers except for D.